Hello. So I have a few things written down here before you. So I just would like for you to take the time right now to write down what you see on the screen as I'm explaining it to you. So last class, what we talked about was tree diagrams. We talked about how to organize all of the different possibilities of and probabilities of certain events happening by talking about all the different branches that could come out of a certain event. So now we're going to talk about Venn diagrams, which is just a different way of looking at it and a different way of being able to see the picture as a whole. So you've seen Venn diagrams before. We've got these two circles that have an overlapping amount. That overlapping amount is both A and B. A is one set, B is another. And then you also have this space, which you can see like the red bubble around. We have this space that's outside of the Venn diagram that is neither A nor B. So it's important to note that if you see a number that's outside of that, it just means that it isn't involved in either of the sets. We use set notation with this, which we have talked about a lot this year. So hopefully you're starting to get a little bit familiar with them. We have our union. The union of two sets is this word of or. Either this or this, doesn't matter. Just put them all into this bowl-like thing. So the union is everything together. We do have to make sure that there's no repeats. So if we have an overlap and we want to count everything all together, we might count that overlap twice from set A as well as from set B. So you have to make sure that you subtract out the overlap if you happen to add in an overlap. Versus this bridge guy, which is called the intersection. The intersection is the word and. So it has to be both A and B. It has to be in both of them in order for them to be able to connect like that. So it's what they share. All right, we're going to interpret a Venn diagram first really quickly. Notice that there are four numbers in this situation. We have 12, 7, 19, and 4. So 12 is the number that's just baseball and only baseball. 19 is the number that's tennis and just tennis. 7 is the number that people like both baseball and tennis. And then 4 is the people who don't like either of them. So if we were asked about how many people total are in the class, we just have to add up all 4 of those numbers. There are no repeats because I haven't counted a number like that number 7 in either of them, in either 19 or 12. Technically, all of the people that like baseball are 12 plus 7, which is 19. But we're not counting that 7 in that total, so we're just going to add them as we see them. So the total number is 42. The union of the two, which is everything all together, is going to be 12 plus 7 plus 19, which is 38. The intersection is what they share. So the only things that overlap between them, which would be 7. All right. So now we're going to take a shot at making our own Venn diagram. We've got button-down wearers and sweater vest wearers. You should, as a general rule, label your variables for all of these guys. B equals button down, S equals sweater vest. Okay, so if we have 10 teachers who are wearing button-down shirts and 6 who are wearing sweater vests, and then 3 of them are wearing both a button-down and a sweater vest, realize that we have a total of in a group of 14 math teachers. Okay, so we have a group of 14 math teachers and 10 of them are wearing button-down shirts. There are 3, though, who are wearing both a sweater vest and a button-down. So we've got 3 here. That's the intersection between these two Venn diagrams. If there's a total of 10 who are wearing button-downs, then the remainder that are not wearing sweater vests are 7. I just subtracted 3. Versus the 6 who are wearing sweater vests, 3 of them are wearing both. So that means that the remainder 3 here are wearing just sweater vests. Now we have to make sure that we've accounted for all of the teachers. If we have 14 math teachers and we look at this Venn diagram, notice that we've only accounted for 13 of the math teachers, which means that there is one lonely math teacher who is wearing neither. Okay. A math teacher is selected at random to determine the probability that they are wearing a button-down but not a sweater vest. So the number of people who are wearing button-downs but not sweater vests are 7 out of the total of 14 teachers. Create a Venn diagram for the following. In a class of 50 students, 23 like geometry, 22 like algebra, and 20 like neither. So we're going to draw our Venn diagram. We're going to have geometry and then algebra. I'm going to first start with the 20 that like neither. So the 20 that like neither go in this space outside, which means that there's a remainder of 30 who are represented in this situation. So we are not given who likes both geometry and algebra, but we know that there's definitely repeats in there. So what I'm going to do instead of what we did before, I am going to try, and normally I would do this kind of with my hands or just with my eyes and try and think about it in this way. But if I remember, if I have 30 students left and 23 of them like geometry, I could think about blocking out this entire geometry bubble and think of that as 23 who are not that out of the remainder of 30 who are inside of this Venn diagram. From subtracting 20 from 50, we have a total of 30 left. 23 of them are in that bubble, which means that the rest of them, the 7 of them, have to be in the just algebra section. And then I can do the same thing when we're talking about algebra. I can go in here and kind of with my mind, right? But I can't really show you how I do that. I would block out just algebra and think, okay, well, there's 22 who are in that, not even just algebra. There are 22 who are in that whole algebra bubble, which means that there's a remainder of 8, subtracting from 30, who just like geometry. And then now we can figure out, well, what's the number that's in the middle? Well, if 23 like geometry and 8 of them only like geometry, then that means that there's 25 who like both. And then I can just really quickly add these all back up. 25 plus 20 plus 15, and we get, 60. Which is a great reason why we should double check our work. Subtracting 20 from 50, we get 30. And so then the remainder of 30 who are in this Venn diagram, 23 of them like geometry. Which means 7 have to like algebra. Oh, because I did my math wrong. Oh man, guys. Okay. That's because this is supposed to be 15, not 25. So that was just me making a really stupid algebra mistake. But besides that, good thing I double checked my work, and we're good to go. In a group of 40 students, 22 like economics, 25 study law, and 3 study neither. So again, what we're given, so we've got, oh, that's not good. There we go. We've got 22 who study economics, 25 who study law, and then we have 3 who study neither, which means that in the Venn diagram, there will be 37 total students. So then in my mind, I'm going to cover over the economics thing and think, okay, well, 22 are in that bubble, which means of the 37 left, We have 15 who like law and who study law and only study law. Versus if I were to go in and cover up the law bubble, that's 25. So 25 who are in the law bubble. So that means out of the 37 who are in this whole diagram, if I subtract out 25, we have 12 who study economics and only economics. Okay, so if we have 12 who only study economics and who only study economics, but we have 22 who study economics and potentially something else, that means that there's going to be 10. So I take 22 and subtract out 12, which is 10, which works for your 25 as well. I will really quickly double check. And that adds up to 40, and so we're all good. Determine the probability that randomly chosen student studies both economics and law. So the number of students who study both economics and law is 10 out of your number of 40, out of your total number of 40. How many students study economics given that they study law? Well, given that they study law, that means that you are taking only from the pool that study law. So there's a total of 25 students who study law. What is the probability that they also study economics? So then now you have to go in and find, well, what's the number that's both economics and law, which is 10. So 10 out of 25.